Hello, dear student. This is Professor Marwa Osama from the Faculty of Physics at Huari Boumediene University of Science and Technology. This video is dedicated to first year Science and Technology ST as well as Material Science SM. It's in which I will present the first practical session, lab work 1. The core purpose of this lab is to observe how guided car behavior when moving over variable surface. This allows users to establish the empirical laws of the motion and build essential experimental skills. Our experimental setup consists of a specialized linear track with an inclined segment AB and a flat section BC. We utilize spaces infrared photograph linked directly to high-speed digital chronometer to detect the transit time. The procedure flow three distinct steps. First, we initialize the card at the reset at the absolute origin. Second, we resize the card and record the transit duration between the photo gate. Finally, we iterate each run 3 times, minimize the uncertainties. In this video, I give you an example of experimental procedure. Here we see our recorded experimental raw data by taking 3 trials for each distance. We compute the high-level main transit time, which serves as the foundation of our kinematic model. Plotting the position time curve (st) relate the geometric nature of the motion. Notice how the shape shifts smoothly from the upward curve to a linear slope as the time advances. An analytical reading of this curve shows two distinct regions. Phase 1 on the incline display a parabolic shape indicating an uniformly accelerated motion. Phase 2 on the horizontal show a sterile line signifying constant uniform velocity. To determine instantaneous velocity from our discrete position, we employ the second approximation over a small interval of 0.2 seconds. The average velocity becomes mathematically equivalent to a tangent slope. This calculation table maps the computed midpoint velocities. We can clearly see the speed rising linearly of the incline until its level of the exact 0.meter per second. The velocity time graph illustrates this transition beautifully. We observe a linear ramp with a constant acceleration of approximately 1 meter per second squared, followed by a flat horizontal plateau indicating zero acceleration. Mathematically, we formulate this two-phase with classical kinematic equation. Phase 1 represents a uniformly acceleration motion under gravity, where phase 2 is described by simple uniform motion equation. In conclusion, our practical experiment perfectly validates a physical theory. The light barrier stopwatch method gave a predictable transit time agreement within the few milliseconds across the territorial. The measured offset S0 equal 2 centimeters match the value fixed by the experimental setup, validating the timing method. On the inclining, the car undergo uniformly accelerated motion from the reset. A1 equal 1 meter per second squared. On the horizontal line, the motion becomes uniform. A2 equals 0. At the velocity reshaped at the bottom of the incline equal 0.8 meters second. Thank you for your attention. وإلى الملتقى إن شاء الله.